two embedding models over the same documents. The small one is Nomikan Ben text at 274 megabytes. The other is Qwen 3 embedding at 639, so roughly 2.5 times the size. Look at the hit at one column. 69%. 69%. Identical. Quick note before we dig in. If you find this useful, subscribe and drop a topic you want explained in the comments. Now, let us get into it. If you're building anything that searches your own documents, the embedding model is the part that decides what gets found. It turns each chunk of text into a list of numbers, turns your question into another list of numbers, and retrieval is just finding the chunks whose numbers are closest. So the obvious question is whether paying for a bigger one gets you better answers. That is what this is testing, and the headline says no. The headline is also not the interesting part. Stay with me. First, what is actually being measured, including the part that is weak? The corpus is 16 real markdown documents from this project, cut into 264 chunks. Not a public benchmark, which matters because a public benchmark may well be in the training data of both models. The scoring rule is the bit worth being careful about. A hit means the correct source document showed up in the top results. It does not mean the retrieved paragraph contained the answer. A model could hand back the most useless paragraph in the right file and still score a point. I could have graded every result by hand or had another model grade them, but a model grading a retrieval test brings its own mistakes. So this measures the weaker thing accurately rather than the stronger thing vaguely, and now you know which one you are looking at. Here is the harness. Chunk the corpus, embed every chunk, embed each question, rank by cosine similarity, check whether the right document came back. 16 questions, each written before the run and each naming the one document that genuinely answers it. So, the results. 69% each at rank 1. 11 questions out of 16, both models. The small one indexes the whole corpus in 3.8 seconds. The big one takes 14.1, so nearly 4 times longer. On a single query, it is 26 milliseconds against 104. Same score, 4 times the weight. There is one place the score is genuinely separate, and it is worth understanding. If you look at whether the right document appears anywhere in the top 5, rather than strictly first, the small model gets 81% and the big one 94%. So the bigger model is better at pulling the right document into contention. It is just not better at putting it first. That distinction matters depending on what you build. If you show a user one result, rank 1 is your number. If you feed 5 chunks into a language model and let it sort them out, which is what most retrieval systems actually do, rank 5 is your number, and the bigger model is meaningfully better there. Now, the part I did not expect. Both models got 11 right. They are not the same 11. 4 of the 16 questions flip. On the question about why the daily automation kept retrying, the small model finds the right document and the big one does not. Same for the question about the number plate on the thumbnail. Then it reverses on the question about which settings still need a human, and the one about queued short-form ideas. The big model gets it and the small one misses. 2 models, 1 score, 2 different sets of blind spots. This is the thing to take away, because it changes what a benchmark number means. 69% is not a description of a model's ability. It is a count of how many questions happened to fall inside that particular model's competence. Swap the question set and both numbers move, and they will not move together. It also quietly suggests something practical. If 2 models of different sizes fail on different questions, then running both and merging the results should beat either one alone, and that is a cheaper upgrade than buying a bigger model. I have not measured that, so I am not going to claim a figure for it. There is one more row worth looking at, and it is the only question both models fail completely, not even reaching the top 5. The question is what the first things are to fix to make the channel discoverable. The correct document is a growth plan. Both models returned a growth diagnosis instead. Those are 2 different documents about the same subject, written 11 days apart. One says what is broken, the other says what to do about it. They share almost every important word. Similarity is the only tool an embedding model has, and by similarity, those documents are nearly the same thing. That failure will not be fixed by a bigger embedding model, and it is worth being clear about why. The 2 documents genuinely are similar. Telling them apart requires knowing that the person asking wanted actions rather than findings, and that intent is not in the text of either file. This is where re-ranking, metadata filters, and asking a model to actually read the candidates start earning their cost. So, what does 274 megabytes buy you? On this corpus with these questions, exactly as many correct top answers as a model 2.5 times its size, 4 times faster on both indexing and queries. If you only ever look at the first result, the small model is the better engineering choice and it is not close. If you feed several chunks downstream, the bigger model's 94% at rank 5 is a real advantage and probably worth the 100 milliseconds. And in both cases, a 69% hit rate on your own documentation is a lower number than most people assume they are getting. The only version of this test that tells you anything is the one run on your documents with your questions written before you see any results. 16 questions is a small sample, and one flipped answer moves the score by 6 points, so treat a one-question gap as noise. The scripts, the question set, and the raw JSON with every ranking are in the repository below. If your two models come out level as well, do not read that as a tie. Go and look at which questions each one missed. That is the core of it. If this helped, hit like and subscribe, ring the bell for the next deep dive, and tell me in the comments what you want broken down next. Thanks for watching.